All right. Everything that we've done so far pretty much has been the difference of areas. It's the difference between the area under this curve, under the straight line, and the area under the parabola. So it's been differences that we've looked at so far, but now we're going to do a sum question where we need to add two lots of area together. So in question 10, we're given these two functions, y equals x minus 2 squared and y equals x minus 4 squared. And again, going all the way back to the preliminary course, chapter 5 of our textbook, you should know that these two things are parabolas, and that when the constant is inside the working part of the function, so here the constant is inside the working part of the function, then what we end up getting is we get a parabola of its basic nature. It would look like this. We get a parabola, but it's shifted to the right. Because it's a minus 2, it gets shifted to the right 2 units. So let me label my axes. That gets shifted to the right 2 units. There's that one. And you may be able to see quite quickly that it's going to cross the y-axis at 4, but that's not really of great importance to us. So there's the point 2. And then this is another parabola, same shape, shifted to the right, but this time shifted to the right, and its vertex is at 4. All right. Now what we want is we want the sum of these two areas. We want the sum, which means we want this bit added to this bit. And you know what? They're going to be symmetrical, but perhaps you don't know that for sure. So the process will be to find out the point of intersection. Where do those two curves meet? At what x value? I'm guessing it's going to be at x equals 3, but let's check that out for sure. Find out the point of intersection, and then we're going to have two integrals. We're going to have the integral of this function here, y equals x minus 2 squared, and we'll have the integral of this function here, y equals x minus 4 squared, and we'll add those two integrals together. Alrighty, let's first of all find out what that point of intersection there is. So we will solve simultaneously. X minus 2 squared is equal to x minus 4 squared. And if we just find the, is it going to be okay if I do that? Yeah, we'll find the square root of each side. So x minus 2 is equal to x minus 4. And then that would mean, what have I just done? No. So we'll expand these out. So we have x squared minus 4x plus 4 is equal to x squared minus 8x plus 16, and they're going to cancel from each side, and this will become 4x, and that will equal, if I take the plus 4 across, subtract it from both sides, that is, if I subtract it from both sides, that will become 4x is equal to 12, and x is equal to 3, which is what I suggested it would be, right smack in the middle. Now what we can do is, to find the area, it will equal the integral of the integral from 2 to 3 of this curve, x minus 2 all squared dx, plus the integral from 3 to 4 of this curve, which is x minus 4 squared dx. Okay, we know how to integrate these ones. This is the function of a function thing. It's not too bad. In fact, this one's really quite easy because the coefficient of the x term is 1. So in the function of a function integrations, that would be the equivalent of saying that a is equal to 1. Alright, so for this one, we'll have x minus 2 cubed all over 1 times 3, and that's from 2 to 3, plus the integral of this will be x minus 4 cubed over 1 times 3, and that's from 3 to 4. And now as we substitute in these values into the function that we've got here, the result that we've got is 3 minus 2 is 1, 1 cubed is 1, so that will be 1 on 3. That'll be 1 on 3 minus, if I put 2 into here, that will be 0, so that whole thing is going to become a 0, plus, now let's do the same thing over here, it will be 3 minus 4 is minus 1, minus 1 cubed, oh, I've done the wrong thing, 4 minus 4 is going to be 0, minus, now when I put 3 into here, it'll be 3 minus 4, which is minus 1, and minus 1 cubed is minus 1, so that will be minus 1 over 3, and we'll have 1/3 plus minus this minus and that minus work together to become a positive, so that's a plus 3. So the whole answer is 2/3 units squared. Okay, so that's how to find sums and differences of curves. Exercise 3.8, see how you go with that, and email me if you've got any troubles, and I'll try and get to those sometime in January. Alrighty, I'll keep an eye on it. Thank you.